Hi guys, and welcome back to Global Education Zone. And today, in this particular episode of our further mathematics course for SS1, or let's say senior secondary school 1, in this particular course, we are going to be talking about binary operations. Now, binary operations are basically the kind of operations that are carried out on two distinguished classes of mathematical objects. So basically, that's what a binary operation is. So in this today's course, our performance objective are basically, by the end of today's course, we're supposed to have talked about a couple of things, and those things include defining binary operations. You should be able to define binary operation at the end of this course. Then you should be able to identify the different laws of binary operations. Yeah. Then you should be able to draw multiplication table for a binary operation. So basically, this is going to be a very interesting course, and I want you to sit tight and watch it to the end so you can also understand this topic. So without wasting much time, let's go into the details. So basically, the first thing we are going to be talking about today is the definition and the fundamentals of binary operation. And that is why we are going to be starting from the rule of combination. So when we talk about the rule of combination, the rule of combination is basically a rule that determines how you combine two different mathematical objects. So as I mentioned earlier, a binary operation is a collection of mathematical objects, right? So that operation is something you carry out on those mathematical objects. So basically, we have to be able to understand the connection of these mathematical objects, right? So basically, in mathematics, the rule of combination of two elements of a set S may give rise to a third element which belongs to the set S. So basically, when you combine two mathematical elements, you can give rise to a third element. For example, those of you who are going in chemistry, you know that when you combine hydrogen and oxygen, you get water, right? So, but depending on the conditions, so those conditions are the nature of the binary operation. So each binary operation has its own conditions by which it operates. So a binary operation has its own specific conditions. So what exactly is a binary operation? So a binary operation is any rule of combination of any two elements of a given non-empty set. So basically, it is a rule of combination of any two elements of a given non-empty set. So basically, this set is a set that contains elements, right? And these elements, they have their different properties. So a binary operation is kind of like an operation, like an operation, a process you carry out. That operation could be an arithmetic operation, it could be a geometric operation, it could be a factorizing operation, factorials and all the rest, exponential operation, and so on and so forth. So there are different operations you can carry out on. It could even be a graphical operation. So but these operations, at the end of the day, after carrying out these operations on the two elements of those sets, you will get a third element, which may or may not be an element of the same set. For example, if you said we have a set of that contains 5 numbers, which are 1, 2, 3, 4, and 5. Now, if you multiply 1 by 3, you would get 3 as an answer. Now, that your answer 3, which is 3, is also an element of the original set. So this can lead to different situations, which we can explain as follows. So basically, that is what we know as closure property. Now, the closure property has to do with the fact that a non-empty set S is said to be closed under a binary operation if for all a, b element of S, a operation b is also an element of S. So that is what you should understand. So what this means is that if the product of your operation is also an element of the original set of elements, then that original set is said to be closed under that operation. So what you know is that we are talking about different things now. We are talking about elements, we are talking about operations, and we are talking about closure, right? So basically, you have a set of elements. Now, if you perform an operation on any number of elements of that set, and then the product of that operation is also an element of the original set, that means that set is said to be closed under that process. But if the product of that operation is not an element of the original set, then it is said to be non-closed. So that is non-closure. Now, basically, that concept is a concept that I hope you are able to understand. So now let's subsequently move on to some examples on binary operations. So the first example we'll be dealing with here is this set Z. Okay, with this set Z of all positive integers is closed under addition and multiplication, but not closed under subtraction and division. So for example, what this means is that the set Z of all positive integers is closed under addition and multiplication. That means if you perform an addition operation on a set of all positive integers, which is the set of 1, 2, 3, 4, 5, 6, any positive number you can think of is an element of that set. So now if you perform an operation on that set, that means you should get an answer which is also an element of that set. That is called closure property. So the set of all positive integers is closed under addition and multiplication. So if you add or multiply them, your answer is going to be an element of that original set, which is set Z. But on the other hand, the set it is not closed under subtraction and division, right? That means if you perform subtraction and division operation, it will not, your product will not be an element of the original set. So for example, we say 3, 5 is an element of Z, but 3 minus 5 is minus 2, which is not an element of Z. So that is the subtraction operation does not close them. So also in general, if P, Q is an element of Z, then P plus Q will also be an element of Z. So addition always closes the property. So basically we have PQ element of Z, but P minus Q is not element of Z. So these are basically examples and illustration of the closure property that tells us how it operates. So I hope you understand that concept. So after understanding that concept, you can also test yourself. For example, you can test yourself on factorial operation, multiplication operation, division operation, on different kind of, and these operations, they have their different natures, they have their different properties. So you can just test out the properties of operations. Now we're talking about properties of operations, right? So that is why we are going to be talking about different properties of operations. Now these operations, you can start from the commutative property. Now this commutative property is a kind of property that has to do with the fact that when you are given a non-empty set S, which is closed under a binary operation, if for all a, b element of S, a operation b is equals to b operation a, then the binary operation is said to be commutative. So basically what that simply means is that if a operates b is equals to b operates a, then that operation itself is said to be a commutative operation, right? So that example is something we should understand early enough. So I guess it is it's quite explanatory, right? So let's move on to an example that illustrates that. So the example I'm giving here is if P, Q element of R, where R is a set of real numbers, then P plus Q is equal to Q plus P, and PQ is equal to QP. So I'll give an example of this kind of phenomenon which you mostly encounter. So basically, let me give an example. If you have two numbers, if you have a set of real numbers, which is 1, 2, 3, and so on and so forth. Now, if we define an operation delta as the product of this element of two elements of this set, A delta B is equals to A times B. Now we are going to determine whether this operation is closed, whether this set is closed under this operation, rather. And then we also have another operation, asterisk, which is defined by A asterisk B equals to A over B. We are going to determine whether this also gives us an element. This is another set. So let's pick our A as 2 and pick our B as 10. So A equals 2, B equals 10. So now the next step is I want to determine whether which of these that the original set is closed under. So let's pick the first operation, operation delta. So operation delta is defined by, when you have an operation delta, A delta B means A multiplied by B. So that is the value of that operation. So let's say A delta B, that will be, in the first case, this is a test, mind you. So we are trying to test the validity of these conditions. So here we have A delta B. So let's say A delta B, that's A times B, right? That what? A is 2 and B is 10. So that's 2 times 10. And our final answer will be 20. So that is the result of our answer. Then let's try the asterisk operation. So we have A asterisk B is equals to A over B. But A is equals to 2 and B is 10. That's 2 over 10. So now in this case, you can say that in the first case, our answer is 20. And 20 is also an element of the set S. So that means that the set S is closed under the operation delta. But in this case, we have 2 over 10, which is a fraction, and this is a set of real numbers. It doesn't contain a fraction; it contains only whole numbers. So that means this fraction is this set S is not closed under the operation asterisk. So you can see the different outcomes depending on the nature of the operations. So that is what I mean by closure and commutative property. So in this case, this is an example of closure. Now let's go to commutative property. So if A operation B is equal to B operation A, so let's say is this equals to B operation A. Now this operation is a delta, so that's what we are trying to verify. So A asterisk B is equal to B asterisk A. So let's try in the second part. Let's check if B operation A will give us the same answer, 20. So B operation A is B times A. That what? B is 10, while A is 2. 10 times 2, which is 20. Let's go to the next one. B operation A here will be B over A instead. That what? It's just like inverting the elements. That will be B is 10 and A is 2. That's 5. Now, commutative property is tested by if the first answer is equal to the second answer, then it is commutative. So here we have 20 as the first answer, and that is also equal to the 20 as the second answer. So that means our operation is totally commutative. So you get it. Now in this case, we have in the first answer we have 2 over 10 here, which is not equal to 5 in the second case. So this is not commutative. That is how you test commutativity of an operation. So let's move on to something else, which is associative property. So when we talk about associative property, it has to do with the fact that you can actually associate these elements with. You can actually associate an operation with another operation, and you will still get the same answer depending on your what you expect to get. So basically, as you can see the screen, first of all, let's start with the assumption that we have a non-empty set, right? So we have a non-empty set. Now in that set, we have something that we need to understand basically. So in the first case, we have suppose a non-empty set S is closed under a binary operation asterisk, yes, then A comma B implies that A asterisk B is an element of S, yes. That means A asterisk B can also combine with C element of S, and when we write the result as A asterisk B asterisk C. So basically it means that you are operating on A asterisk B first, then you now operate your product with asterisk C. So that asterisk is a product itself. So that means A operation B, you calculate that one, then you are now going to do your answer operation another element of the set. So that's what associative property means. So the bracket stress the fact that the operation asterisk will combine A and B. So basically your answer means that your operation, your first operation will have to combine with the second, right? So basically so from what is on the screen, basically you have that result A asterisk B asterisk C and A asterisk B asterisk C means may or may not be equal. So basically that is if a condition for us to check the associativity of a particular operation. So let's do an example here to verify that. Let's check that if that is actually true. So here we have a particular example we want to use and check. So but let me give the basis for this associativity. So for something to be associative, we need it to be that we need the operation of A operation B, the operation of two elements of that set must operate with another element of that set, operation C. So and then it must also be equal to the operation of the first with the operation of the second too. B asterisk C. So mind you, this often works with two pairs of elements. So basically, if you have three elements here, we are going to operate the first two with the third. If you have three elements here, so you are operating the first with the second two. So basically, it's what is changing. The only thing that is changing here is the grouping. You are grouping the first two here, but in this second case, you are grouping the second two. So don't forget that. You're grouping the first two, grouping the last two. That's the basics of this. Now in this case, let's try and see if this is correct. I'll give an example from my book. So here we have that we want to test an operation. So yes, I like this question, which is that Yeah, we have this question which is not very difficult, but let's try it. So get ready for this question. It's quite tricky. So we have A asterisk B. A operation B is defined as A plus B plus AB over 2. So this is how it is defined. Our operation is defined as A plus B over AB plus AB over 2 rather. So now in this case we are trying to determine whether this is associative. So basically what we are first going to do is we are going to try and operate on A asterisk B. Then we'll now operate it with asterisk C. So basically we have 3 elements. Let's pick 3 elements. Okay, no, we don't actually need to pick 3 elements. We can just use a hypothesis based check. We want to check now. Yeah, so guys, we're back, and here we want to test the effects of operations like this. So basically, first of all, we have A operation B equals A plus B plus A over B, AB over 2, right? So now that means A operation B is A plus B plus AB over 2, which is static, yeah. So now we are going to test that A plus B operation C will be equals to A plus B operation C. So A plus B grouped here in the first case, and A plus B plus C grouped here in the second case. So in the first case, we have this given to us. Now if we are operating this with C, what we get? So we have that A plus B, sorry, that's not plus. I meant to say operation, not plus, operation rather. So that means A operation B equals A plus B plus AB over 2, right? Now in this case, we are going to look at it now. Let's give our answer for A plus A operation B, which is A plus B plus AB over 2, right? So that means that will be A plus B plus AB over 2. Now we are going to take this as one side, then we are going to operate this with C, option C, right? Now let's check that out. So that would be so I'm aware of the fact that you guys probably cannot see the screen, right? So because of this reflection of the sun, right? I'm actually outside right now, so I will correct that now. Yeah, so guys, I hope I've been able to actually okay, the board is quite clear now, I guess. So actually this is one of the troubles of a video creator. I have to cope with lighting and all the rest. So now let's continue for another stuff. So yeah, I'm trying to verify some stuff, and I hope you can see the board. If you can't see the board, please tell me in the content anything you want me to do to improve the display and the processing of this video, how this video looks. If there's any issue with the board, if there's any issue with the lighting, let me know in the comment of this video. Thank you. Now let's move on. So we are operating this with this, right? So in this case, now look back, we are taking this one as a single left side of this particular equation, and we're operating it with C. So now let's take it as A now. Assuming it is A, just in your mind take it as a single thing. So this A operation B, which this one on its own, A operation B equals A operation C equals A plus B plus A B over 2. So this one, in this case, we are going to replace B with C. So that will be this operation C. Anyway, C be replaced with C. That will be this. Let's say again, that's A plus B plus AB over 2. Then plus B. B is now C. We are replacing it with C. So, but we are not replacing the B in this original A. It will be like that, but the C, which is outside, is what we are going to be changing. So plus C plus AB over 2. So that means you are going to multiply A by half B. But in this case, we are replacing B with C, as I mentioned earlier. So we'll multiply this with half of C. That will be C over 2 plus C over 2 times A plus B plus AB over 2. So next let's move on to something else. That will be equals to, that will be A plus B plus AB over 2 plus, now let's factorize this. That will be C plus, let's expand this. That will be C over 2 times A, that's AC over 2 plus C over 2 times B, that's BC over 2 plus C over 2 times AB over 2, that's ABC over 4. So I hope you understand the basics of multiplication like this. So but if you don't understand the basics of multiplication, you can check out my videos in this channel where I talked about multiplication and all the rest. So that is the basic mathematics. And if you still don't think that is basic enough, we'll still talk about the basics of mathematics. So that should do. So next let's talk about something else, which is the second, the right hand side of this equation. Let's deal with the right hand side of this equation. So this is the left hand side of the equation. We are done with this. Let's just leave our answer like this, or we can still factorize it, right? So let's do that. Let's still do that. So this is our answer. Our answer is in this form, right? So that's our left hand side. That's the left hand side of the equation. So let's still factorize it, right? Yeah, we should. So a plus b plus a plus c. Yes, plus c. We forgot the c. That's just a c. That's just a plus c before this bracketed term. So that what a plus. Let's group the single terms. That was a plus b plus c plus ab over 2 plus ac over 2 plus bc over 2, then plus abc over 4. So at the end of the day, our answer will be a plus b plus c plus half ab plus ac plus bc, then plus quarter 1 over 4 abc. So just in case you cannot see the writing on the board, I will display the solution. So I hope you can see it on the screen right now. That is the solution of the first part. That's the solution of the first part. So let's talk about the right hand side of the equation. Now we want to check whether they will be equal. We want to verify that. So the second part of the equation. So guys, let's move to the second part of the equation, which is the right hand side of the equation. So in the right hand side of the equation, we have that that is A operation B operation C. But from the definition of operation, we have that B operation C, that will be A operation, B operation C, that will be B plus C plus BC over 2, if you agree with me, from the definition of this operation, from what we have here, the definition of the operations. So I can see that the marker is quite not clear enough, right? So let me do a change. So guys, I've done a refill. I told myself that this 2023 I will be doing very quality videos, so you can see that I'm doing my best to actually be quite meticulous. Yeah, very good. So now let's continue. The marker is now refilled, so I hope you enjoy this video from now on. So that's equals to, so now we have that so let me write it again so you can see it clearly. So that's A operation B plus C plus BC over 2. So this is what we have here. So now in the next aspect, now let's move on to something. Let's evaluate this. So that's what the definition of an operation itself. It is basically you are carrying out you first of all add the two sides, then you multiply the first side with half of the second side from the definition of operation which you have here. So that means let's start that. That will be the A plus the second side, which is B plus C plus BC over 2. Then the last thing is we'll multiply them, and that's plus. So the first side multiplied by half of the second, that's A times B plus C plus BC over 2, then over 2. So that will be what? A, let's open this bracket, A plus B plus C plus BC over 2. Then the second, then last one, plus A over 2 multiplying B plus C plus BC over 2. So opening together will be A plus B plus C plus BC over 2 plus AB over 2. When we open this bracket, then plus AC over 2, open the bracket, then the last term plus ABC over 4. And that's what? A plus B plus C plus BC over 2 plus AB over 2 plus AC over 2 plus ABC over 4. So at the end of it, that will be A plus B plus C plus, when we factorize this 2 out, that will be plus 1 over 2 multiplying BC plus AB plus AC. Then lastly plus quarter ABC. So that is our solution here, and if you remember the previous solution we got, you will agree with me that this is actually equal to the previous one, because the first solution is we got this same thing. So in the second solution, you can see that this second solution, which I have displayed on the screen now, this second solution is almost the same, but the only difference is that our terms are different. So basically, you might have missed the arrangement of terms. So yeah, their AB came first, followed by BC, followed by AC, but it's still the same thing. In mathematics, your arrangement of terms does not matter as far as you are doing an addition or a multiplication operation, because addition and multiplication, they are generally commutative, so they basically give the same answer no matter which order you put the terms. So I hope you understand that explanation. So let's move on to another concept in this topic. So I hope you enjoyed this video. Let's talk about distributive property. So the distributive property has to do with the fact that so far we have only considered one binary operation, which is on an non-empty set S. So sometimes a set S can be closed under two or more binary operations. So when we're talking about more than one binary operation, we're talking about distributive property. So in this distributive property, we have the fact that this is on a non-empty set. So basically, in this distributive operation, we have that if for all a, b, c element of S, then a option a asterisk b delta c is equal to a asterisk b delta a asterisk c. So if that is equal, then it is said to be left distributive. So but if we have that b delta c asterisk a is equal to b asterisk a delta b c asterisk a, that means it's called right distributive. So it might look as if what I'm saying is jargon, but let me write that on, but so you can understand it better. So okay, I guess I have to clean the board. So guys, we've come to another section of this video, and here we're talking about distributive property. So now let me explain the distributive property. In this distributive property, we're talking about the fact that for example, let's talk about this first one. If we have three elements a, b, c, which are elements of a set S, let's say a set S, so we will represent that mathematically as a, b, c elements of S. Now, if you don't understand this notation, you can check the first video of this course, which I talked about sets. So in the first episode of this course, we talk about sets. You can check it out. Further Maths Part 1 in this course. You can check it out. So now let's talk about the next one. So we have a, b, c element of S. Now let's talk about the notation. So when we talk about left distributive, that means that a operation b delta c will be equal to a operation b delta a operation c. So this notation itself, it is a kind of notation that it's quite, it might look confusing, but it's actually obvious in mathematics. For those of you who have a little bit of knowledge in mathematics, you agree with me that 5 times open bracket 2 plus 3 is equals to 5 times 2 plus 5 times 3, right? So the same thing, this is the same thing we are doing in this first one. So a operation b delta c equals a option b delta a option c. In the same way, 5 times 2 plus 3 is 5 times 2 plus 5 times 3. It's now like when it's like as if you are factorizing the term in the bracket. So that is distributive property. This has to do with the left distributive. But if this lone term is at the right hand side, then to be a right distributive, and it's still the same way, just use algebraic method to evaluate it. That is basically what the distributive property has to do with. So I can see that this video is actually getting quite long, so let's move on to another concept, which is going to be the example. So we're going to be given an example on this and the example goes thus. We have example. This example here, we are told that the operation asterisk and delta are defined on the set R of real numbers by a operation b equals a plus b over 3 for all a, b elements of R. Then we also have a delta b equals ab for all a, b elements of R. So does the operation delta distribute over the operation asterisk? So now they're asking us, does the operation delta distribute over the operation asterisk? So we don't know yet, but let's try out. Let's find out. So this is how we do it. So they're asking us whether it distributes, so let's try it. So in the example, we have a delta b delta open bracket b asterisk c equals a delta b plus c over 3. So that is from definition of the operation, which says that a operation b is a plus b over 3 and a delta b is ab. So that means a delta b plus c, you have to convert the operation to their various numerical values. So next, move on to evaluate that. That will be a delta b plus c over 3. That will be a times b plus c over 3, because delta is a multiplicative operation. So at the end of the day, we have an answer as ab plus ac over 3. So let's go on to the right hand side of the equation. So a delta b asterisk a delta c. That will be ab times delta ab asterisk ac. So at the end of the day, we have ab plus ac, because delta is an additive operation, right? At the end of the day, we have ab plus ac over 3. So that means the left hand side is equal to the right hand side, and that means the operation delta distributes over asterisk in this example. So now the reason why we have delta distributes over is because delta comes first in this example. But I didn't mean our asterisk comes first. We say asterisk distributes over delta. So that is just the way you should understand this concept. So that was that concept. I hope you understand that concept in this video. Let's move on to something else. So next, we're talking about the inverse element. So the inverse element is the concept you need to understand. It's not very difficult for you to understand. Now, this inverse element, we are talking about the fact that we have a non-empty set S, which is closed under a binary operation asterisk. So if x element of S and we can find that element x complement element of S, such that x asterisk x complement equals to x complement asterisk x equals to e, where e is the identity element in S under asterisk. Then x complement is called the inverse of x. So basically, this inverse element has to do with the fact that there's a concept known as identity element. So for you to understand this concept, you need to understand what we mean by identity element. So which is what I'll be explaining consequently in this video. So now let's talk about identity element. So identity element. Now this identity element, we have the fact that an identity element is basically an element that it is quite special in a So where are we? Identity element, right? Now, I said an identity element is kind of that element which is quite special in a particular set, right? And what about binary operations? An identity element is a kind of element that does not give any effect on any element of the set. So basically, whenever you operate an element of the set with an identity element, that identity element will have no effect. So for example, that means that, for example, if we have an element A operates an identity element, let's call it E. Now A operation E will be equals to E operation A, and at the end of the day, we'll still get our original element A. So this is a statement that is talking about the property of an identity element. So in this case, we have A operation E equals E operation A, which equals to A. Now, in this case, it is quite explanatory, right? But now, what about the inverse element? It's a kind of element which gives us an identity element when you operate it with the original element. So the inverse of an element from mathematics, from normal mathematics, you know that the inverse of an element is kind of like an element which kind of which when you operate it with that element, it gives you a value of 1 or it gives you a value of 0. So if it is additive inverse, it gives you a value of 0. If it is multiplicative inverse, it gives you a value of 1. So an example of that is 2 multiplied by 1 over 2. That will give an answer of 1. That is multiplication inverse. But additive inverse, 2 minus 2. So 2 plus minus 2, that will be 2 minus 2. That's 0. That's additive inverse. So in this case, in general, we're talking about we're dealing with different kind of inverses here, right? So the law of an inverse element is that when you have an element M operating its inverse, M operation M inverse equals to will be equals to M inverse operation M inverse operation M, and now equals to M will be equals to the inverse element, rather not M, equals to inverse element equals to E. So this is the concept you need to understand. The operation of an element which is with its inverse is commutative, and it gives us an answer, a product. It gives us a result of the element itself. So that is the concept you need to understand. This is something that is very explanatory. We can deal with it using an example in this course. So let's move on to an example that will help us to understand the um, the effect of inverse elements. So now in this example, we're talking about inverse elements, right? Let's do something about that. So we have this example on the screen. So in this example, we have that in this example we have that an operation asterisk on the set R of real numbers is defined by A operation B, A asterisk B rather, A asterisk B equals 2A plus 2B minus 3 over 2. Now, for all A comma B element of R, so find the inverse of X element R. Now, basically, in this example, we are dealing with something which we have to understand basically. So in this example, we have that so first of all, we have to find the identity element. So now, identity element and inverse element, they are tied together, right? So let's find the identity element first. So in this identity element, we have X option E equals X, right? That's for identity element. So that means X option E equals 2X plus 2E minus 3, then divided by 2. So when we do that, we will get 2X plus 2E minus 3 equals 2X. And when we solve for X, we have that when we solve for E equals 3 over 2. So that is the identity element here. So we use the identity element to solve for the inverse element. So in this case, let's move on to inverse element. So we know that the operation of an element and its inverse, from what I explained earlier, is equal to the identity element, right? So that means X operation X inverse will be equal to identity element E. That's X. So when you convert that operation, so 2X plus 2X inverse minus 3, then all over 2 will be equal to the identity element, which is 3 over 2. When you solve that, you have X inverse equals 3 minus X. And that's the answer. So that is the value of the inverse element for this question. So the inverse of an element can differ. So there are different kinds of inverse, and those inverse, they are affected by the operations. For example, if we are doing a multiplication operation, the inverse will be equals to the reciprocal. If we are doing a an additive operation, then the inverse will be equal to the negative of that operation. So but this operation, this is a wider explanation for inverses. So I hope you understand this concept. Now let's move on to that's as far as we'll go in this video. I hope you enjoyed this video. So let's move on to the summary of what we've covered here today. So I hope you enjoyed it. I know it might have been a little bit long, but I'm very sure you enjoyed it. So this is a summary of what we've dealt with in this video. So in this video, we'll talk about a couple of stuff. So yeah, first of all, we'll talk about binary operations. We'll talk about non-empty sets. We'll talk about commutative property, distributive property, and associative property. So just go through the summary and let me know in the comment section below which part of this